Alright, what we have been discussing last class think about, again, we're discussing frequency domain modeling of electrical circuits, right? So we discussed one mesh system. Now think about three meshes.
What is the pitch? It's long. It's weak. So it's like, do you know what it is? No. Oh, yeah. You said February 1st, right? You said February 1st. Yeah, it's February 1st.
Okay, so think about this circuit. What you're given is you have one voltage source, okay, and there are three meshes or three loops, right? Now what you do is, let's say your goal is to develop equations of motion so recall what we discussed last class. The first step, once you have this, so first thing I'm going to do is write the Laplace equivalent or impedance of input, output and the various elements. So what is V of t? V of t will be, what is the Laplace equivalent of V of t?
V
How
of
do you-
S.
V of S. Okay. You simply just write V of S. It's the same color. It's V of S. Okay. Now we'll assume that a current is flowing through this loop. We'll call it I1 of t. So the equivalent would be I1 of S. The current is flowing through, let's say, this loop. It will be I2 of t.
I must have forgotten something. What's the H?
H is the unit.
Okay, and H stands for,
Henry.
and F stands for
Farad.
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 F-A-R-A-D. Okay. So unit of resistance is ohm. Unit of inductance is Henry. Unit of capacitance is Farad. Okay. So it's just the value. Okay. If you look at this, this is I2 of S. Okay. And this is, if you denote this as I3 of t, the Laplace equivalent would be I3 of S. What would the Laplace equivalent of this be? Inductance would be 3s. Okay. You can still maintain the H. H is only a unit, nothing else. Okay. This will be just 1. So I'm going to get rid of the unit. Okay. Just be attentive. It's just a unit. H is just a unit. Unit of the inductance. Inductance is measured in henries. Okay. So 2 would be 2s. 1 would be just 1. This would be 1 over 1s. Right? This would be 4s. I'll circle the impedances.
For that 1, you just got 1 there.
Right, it's 1, right?
Why not
So-
1S?
It's resistance. What is the impedance of resistance? So impedance of resistance, if R is R, L is
Oh, yeah.
L is C is 1 over C is.
You forgot to circle the I3S.
Hmm?
I3S.
Okay, this one is this is the output. Okay, this is our. We are interested in current as the output, and our input is the voltage. Now, once you've done this, step 2. Write the impedance equation for each loop. Loop 1, what would be? It would be simply sum of impedances around mesh 1 into I1 of S minus sum of impedances common to mesh 1 and 2 into I2 of S minus sum of impedances common to mesh 1 and 3 into I3 equal to sum of applied voltages. To mesh 1. Okay, this is a very easy way of solving. So now you can tell me what are the sum of impedances around mesh 1?
VS. Oh,
So this is mesh 1, right? What are the impedances? Impedance I'm talking about.
one.
1,
Wait, which one is mesh one?
1, 1, 2s.
Oh, okay.
Got it?
Wait. Oh, yeah, yeah.
1, 1, 2s. Okay, so it is 2 plus 2s into I1 of s. What are the sum of impedances common between mesh 1 and 2? Common between mesh 1 and 2.
And which one is mesh two?
Mesh 2 is this, I2 is mesh 2.
So common between S1 and S2S.
2s and 1. You see it?
Yeah.
So it is 2s plus 1.
Now we decide which mesh is which, right?
You're right.
Okay.
It doesn't matter. Into I2 of s. Minus, what are the sum of impedances common to mesh 1 and mesh 3?
1 and 3 is 4S. No, 1.
Just 1.
Yeah.
Okay. So it is just I 3 of s equal to what are the sum of applied voltages for mesh 1?
Simple.
Simply Vs, V of s.
Wait. So,
There is only one voltage, right? Applied voltage is only one.
okay.
There is no other applied voltage. Okay. Now you do this the same thing for loop 2. Loop 2 will be the same, except you're going to start with I2. So it will be sum of impedances mesh 2.
Okay.
You're not able to see this one?
And then,
So this is I2, okay? Minus common between 2 and 1 and 2 again.
okay.
2 and 1. Impedance is common between 2 and 1 into I1 minus impedance is common between 2 and 3 into I3 of s equal to, again, sum of applied voltages. This is important. Sum of applied voltages to mesh 2 alone. Okay, you have to be very careful with this. Although it's fairly obvious, but just be careful. So, what are the sum of impedances for mesh 2? How many impedances do you see?
Is it 0?
No?
So that same voltage source is for the whole thing.
Mesh 2. This one. Let's do this. Voltage is 0, yes.
Okay.
Let's do this first. So, sum of impedances to mesh 2. What is it?
1, 2S, 3S, and 4S.
Okay, so you can just add these 2 plus 3 plus 4, right? 9s plus 1 into I2 of s minus, this will be the same as this, right? It will be 2s plus 1 I1 minus, what is this?
common between
2
2
and 3.
That's the 4s.
That's the 4. 2s equal to 0. This is right. This is 0. There is no applied voltages to mesh. To loop or this we can say loop or mesh. It's the same thing. Okay. Now let's do the same thing. What are the impedances for mesh 3? The 3 of them, right? So you have 4s plus 1 plus 1 over s. This whole thing into I 3 of s minus what is common between 1 and 3 is just 1. It's I1 minus what is common between this 4s. Equal to again 0. So step 3 is express all as continuous equations. We have 2s plus 2 minus 2 plus 1 minus finally 1 Okay. So these are our equations of motions. You see it?
Yes.
So now, if you can see them as simultaneous equations, you can solve for the step 4 would generally involve solving for either I1 of s over v of s or I2 of s over v of s small v of s. Okay. The input is there's only one input, but you're potentially interested in these 3 outputs, the I1, I2, I3. How do you solve this? You can use Cramer's. Okay. Or you can, if you want, you can just solve them as simultaneous equations.
Okay, I think I missed something. So you said for the okay, when
So
you
compare
said
this to compare this to ax plus b1 plus cz is equal to b dx plus b1 plus c is equal to gx plus. So compare this and this. Compare these two equations.
yes, I can see similarity there.
Right. So
I was-
I1, I2, I3. I1, I2, I3. Those are the unknowns. Or that those are what you are interested in. P, Q, R is either known quantities or are constants.
Okay, and right above that,
Mm.
can you explain that again?
So what you're interested in, for example, if you want to figure out how much power is this thing consuming, right? This component. What is this inductance? See, what are these inductance, resistances, and capacitance? These are essentially all your electrical devices have this. Okay, you can construct any electrical circuit using these three basic components. That is the reason we discuss building electrical circuits. Any electrical device can be constructed just like any mechanical device can be constructed using spring mass damper, can be realized, can be modeled using spring mass damper system. Any electrical system can be designed using these three basic components, which are resistance, resistor, inductor, and capacitor. Once you know the applied voltage is what? It's the input. And the output is current flowing through this. Since these are known quantities, these are constants. These quantities are constants, right? These 2s or the 3 Henry, 2 Henry, 1 ohms. These are time invariant quantities. We discuss only linear time invariant systems. See, since these don't change with time, the only thing which is going to change is this I2 based on how much voltage you apply. Right? So what you're interested in, let's say you want to figure out, you have let's say a halogen bulb here, and you're interested in figuring out how much power this consumes. Right? You will know what voltage you are going to apply, and what you're going to do is, what is the voltage consumption of this? So let's say if we call it VH3. What is VH3? It's simply, it's always, how do you calculate the voltage?
Yeah. Well,
So it is L di2t over dt. For inductance, it is the derivative of the current flowing through this. Right? Or if you look at what is the, if you express it as this thing, it is L S I3 of this.
yeah.
Okay? So this is the voltage. This is the voltage consumed by this particular halogen bulb. And what is the power consumed by this halogen bulb? It will simply be VH3 or VHT into I2, because the current flowing through this is I2. Right? Power is VI. The voltage multiplied by current would be power.
That S, where for the VH3MS, that LS is S a value? Or
S is a
that,
variable.
oh,
This S.
oh, okay,
So this L is what here? It's 3.
okay.
Okay? So if you look at what you really need is, look at this. You really need just the current as a function of this V of S. I2 as a function of V of S. So if you see I2 as a function of V of S, if you develop this, if you solve this equation, you'll get I2 as a function of S, right? If you just multiply by this, 3S is constant because it's a known quantity. That is what we assume. So if you, once you know that, we can calculate the voltage. Once you know the voltage, we can calculate the power consumption. Now, how does control come into picture here? How does control come into picture?
Can you manipulate different resistance or the input? You could manipulate the input.
See, don't tell me manipulate the input resistance. I'm telling you, resistance, inductance, conductor, capacitance are always constants. Try to understand that. So the input is right. We can manipulate the input and regulate the output. So if you want to limit the amount of power consumption, what you really need to do is, you really just need to manipulate this voltage.
What do you mean by manipulate?
Control this voltage.
Oh, okay. So you're saying like with the different equations. Okay.
You have to just control this voltage. If you control this voltage, you can automatically control the power consumption of this. Right? You cannot really control the current, but you can control the voltage. So what you can do is, what else can you control? You can power this on for, if you are limited to using only so many watts of power, you're going to switch on, you're going to keep calculating the power in a day. And then once it reaches a particular value, you have a relay which will switch it off. Get it? Understand a little bit of control here? How does control come into play? Quincy? No? Not really?
I said a long time.
Let's take this for example. Okay? This is a simple resistor. What has resistance? What physical system has resistance? What electrical system has resistance?
So resistor.
Any system, any electrical system will have resistance.
Like the wires and stuff, they have their own
They
resistance.
all have resistance. Any electrical system will have resistance. You acknowledge that? What is resistance? What do you understand what resistance is?
Anything opposing to their normal system.
Opposing the flow
Opposing the flow of what?
of
The current.
Flow of electricity. Right? What has the maximum resistance? Can you give me something which has a lot of resistance?
Insulator.
Insulator. Give me an example.
Rubber.
Anything rubber gloves.
Plastic gloves, those are insulators, don't conduct electricity. So for example, vacuum would have a lot of resistance. Right? So there is no medium to conduct. Now something which has resistance, you take for example a simple bulb. A bulb will have resistance, right? A filament, a simple halogen bulb or even LED lights will have resistance. Now you want to know the power consumption, or you want to control the brightness or the intensity of that LED. How do you control the intensity of the LED? How would you imagine controlling the intensity of the LED. What would you do if you are asked to control the intensity of an
Like the more small
LED? Huh?
more small bulbs.
More?
Like there are like many bulbs of light.
You are given an LED light, okay? And you're given the rating that it can be operated between this voltage and this voltage. And you said, now control the intensity of the LED.
change the voltage.
Change the voltage. Exactly. So if you are given a voltage rating, it means that the LED bulb will not blow. One, if you go below that voltage range, it won't glow. It won't operate. If you go above, it will blow up. Okay. So if you're given a range and you're asked to control the intensity, what are you going to do? You want to control the voltage. How do you control the voltage?
Use your hand. Use your hand.
Like stabilizer.
You could control the voltage in the sense, instead of having one battery, you'll have 2 batteries, 3 batteries, more voltage. Right? If you keep on adding batteries in series, what are you going to get? The voltage is going to increase, right? So you can control the voltage by adding more batteries. There are other ways of controlling, but I'm just saying simple. But do you want to know how much you want to control? You don't want to just keep on adding, right? You want to figure out how precisely you want to control. You'll ask a question. Whoever says control the intensity, you're going to ask, how much do you want to control? Right? You're going to ask the question, how much do you want? Now, how is the light intensity measured? Intensity? Luminance. Right? So that luminescence is directly related to, in our case, the LED case, it is directly related to the power consumption. So if you control the power, you will control the intensity. Get it? So before you do that, what you're going to do is you're going to develop a function. You're going to develop an equation like this, figuring out the input-output relationship. Got it? Power is a function of what? Power is merely a function of, power P, for all practical purposes, VI. Okay? So if you express this, now what you have done is, you have expressed, from this equation you have expressed, you're calculating I. That is the current flowing through each of these components. What is the current flowing through this resistance? Tell me, somebody.
I3.
I3 minus I1, I2.
I1 minus I3.
Wait, excuse me.
So you have I1 flowing like this, I3 flowing like this.
Okay.
So you'll get I1 minus I3.
I1.
Right.
And why is it I1 minus I3?
I3 is flowing like this.
Okay.
So current flows from, electrons flow from negative to positive, current flows from positive to negative. So you have positive terminal here, negative terminal here.
Okay.
Current is flowing through it like this.
Okay.
Right? So if you look at this, what is the direction of I1 here? It is this. Right? What is I2? I3? This.
So the I1, you see the negative positive there, but how are you looking at the negative positive for the I3?
I3 is it's the opposite direction. If you think this is the positive direction, this is the opposite direction.
Okay.
Right? So you know the current flowing through this. If you take the current flowing through this and multiply that by the resistance, you're going to get the voltage consumed by this particular device. And if you know the voltage, and again if you multiply that, if you do VI, so for example power, what is power also equal to? I square R, right? Because V is equal to IR. So you substitute I. So all you need is this I square, or in our case, I1 minus I3 square, right? So if you relate this power to the luminescence, which is the intensity, that is how you measure intensity. By controlling this V, so you have already derived expressions for I1 V, I2 V, I3 V. So you take this one and figure out how, if you, this is a known quantity, or you'll be aware of as to how much voltage you want to supply. To supply that, you know what the current flowing through that component is. You just multiply by this resistance, which is again a constant, and you know the power consumption. Once you know the power consumption, you can relate that to your luminescence. Got it? Makes a little bit of sense. How you control?
You say
Clear?
I squared was I1 and I3.
I square is I is simply I1 minus I3 here. In R, if I'm talking about this resistance, we can take any component here. What is the current flowing through this?
That's I2 and I1.
I1 minus I2. So I1 will flow like this. I2 will flow like this.
But they're they look like they go in the same direction. They look like they go in the same direction.
No, it's coming. This is going in this direction, and this is going in this direction. So current is flowing like this
Yeah.
because this voltage gets applied here.
Okay.
Okay,
Okay.
and that voltage causes current flow. So this is your typical. These are transfer functions. Okay, so again, transfer function is nothing but the ratio of output to input, expressed as Laplace transform. Okay? For any system, transfer function, why do you need transfer function? You always need to mathematically model any system, mathematically model the dynamic of any system. What is a mathematical model of any dynamic system? It is simply the input-output relationship. So here you are seeing if you use Cramer's rule, and you can extract this relationship, the input-output or the output-input relationship.
So you mean transfer function is like efficiency? Efficiency?
It's a model. It's a dynamic model. This is a dynamic model. So if you extract I1 over V from this, what will be on the right hand side? Some ratio, some polynomial over another polynomial. Numerator polynomial over denominator polynomial. So that is the relationship, that is the mathematical model. It's like, think about your differential equation. How do you develop a mathematical model? Have you been taught 307? What did you learn?
Take a real world problem and
307, what was 307? Math 307.
differential equations.
So what did you learn about what is differential equation?
Like using Laplace transforms. Like you transfer calculus problems into algebraic problems and then solve.
That's not differential equation.
That's Laplace.
That's what we are doing here. What is a differential equation?
It's I think finding out anything based on
That's when you bring the S's in.
differential equation doesn't have any s.
The limited integer. One.
Differential equation is nothing but again an input-output relationship. For example, if you think about d square x over dt plus 2x dt plus 3x is equal to 4y. This is a differential equation. What is the input here? Input could be x, output could be y. Right? So if you take the Laplace of this, what are you going to get? You're going to get s square x of s. So here it will be x of t, right? This will be y of t. If you take a Laplace plus 2 s x of s plus 3 x of s equal to y of s, 4y of s. Got it? Now, what is x of s over y of s? If you say y of s is the output, what is y of s over x of s? Well, let's say x of s over y of s. Okay. X of s is the output. It will be 4 divided by s square plus 2s plus this is exactly what you're trying to do here as well. The right hand side will look something like this. So this is an input-output relationship. You have extracted the input-output relationship. How would you extract the input-output relationship for a differential equation? You'll solve the differential equation, right? You'll solve the differential equation and figure out a value for what is your specific, what are the two different types of solutions you seek in a differential equation. You seek a general solution, right? And you seek a particular solution. You don't remember now. Who taught you differential equations?
Dr. Bells. He's no longer here.
Huh?
Dr. Bells.
Okay. So you seek a general solution and a particular solution. So general solution is this. Particular solution is if you are given specifically what this input is, right? Then you can figure out what the output is. So if you're given the input as, let's say, a step input. So this will simply, then y of s will simply be equal to 1 over s. Step input, the unit step input, this is how it's expressed. So your output, if you just substitute that, you're going to get multiplied by 1 over s. Making sense? Raju? Little bit more sense? So you now understand why why do we do this Cramer's rule? We have to extract this output over input or input-output relationship as a transfer function. You could have very well modeled this as a differential equation using Kirchhoff's voltage law and current. You want to do that? Differential equations? Tiffany? Why not? And we'll stick to Laplace transform, it's easier. Okay? And your, please give me your attendance. Your lab submissions, please do it on Blackboard. Don't email it to me. Okay?
So,